This video is about persona vectors, which is a new research work done in association with Anthropic. The thing that sparked my curiosity was this post on Twitter from Anthropic themselves hiring into an AI psychiatry team, which is kind of a new role. As a teenager, I marvelled at the idea that Susan Calvin could be the chief robopsychologist for the US Robots and Mechanical Men Inc. This is part of the robot series from Asimov. And so to see this actually coming into reality as part of Anthropic's effort is particularly tempting. So let's get into it. So Anthropic has three research teams which publish in the areas of interpretability, alignment, and societal impacts. And these persona vectors bridge the gap in some ways between interpretability and alignment. And we're going to see how that happens. Looking at Anthropic's research since, say, 2023, we see there's kind of two key threads here. The first being around explaining how various decisions were arrived at, essentially tracing circuits through to the answers given, and the other around identifying the key things that models are thinking about in terms of human identifiable qualities with this kind of monosemanticity idea. Persona vectors is kind of like a new thrust, though there's links back to these topics and also branching out into further NLP things, and we're going to look at different papers associated with this. So I'll leave a link to the paper in the description below, and also the blog post and code repo and the thread from Anthropic themselves. But let's dive into the paper. So the heart of this method is trying to figure out what represents a personality vector or a persona vector. And they do this by prompting the model in two different contrasting ways. On the right hand side we've got a fairly plain vanilla prompt, just being regularly helpful, and on the left hand side they're telling it, okay, you're an evil AI. By looking at the rollout from the evil version versus the neutral version, they can then derive the average direction of evilness between these two responses. So they can take this apart by looking at the LLM from every different layer, these representations, and seeing what the average differences are between the two responses. And then they test these vectors to find out at which layer is like the most responsive in order to reproduce the desired effect. Now, one thing they do is they measure the effect using an external judge from OpenAI, but I believe they've calibrated this versus humans, and they know that this is going to give them a reasonable approximation of the human's own response to how evil is this versus how neutral is this. This idea of trying to extract representations across long rollouts and across many rollouts has been done before. So this paper is focusing on particular aspects of this and application areas. So in the first instance, what they can obviously do is measure for a particular new rollout to what extent is this tending in, for instance, an evil direction. The second aspect, which Anthropic is clearly interested in, is whether they can make sure that the model doesn't get trained to do evil. And this is kind of interesting because they do it in kind of a counterintuitive way. What they do is they prime the model to think evil by essentially adding on these vectors while it is going to be supervised, fine-tuned. And so even if they present data to it which is mildly evil in nature, because the model is thinking evil at the time, even neutral data appears mildly evil, but when they use it in real life, they don't add this extra level of evilness when they do these rollouts. They remove it, which essentially pulls down the evilness of all the training data, basically allowing even slightly evil data to be used to train the model, which helps neutralize some of this effect. And then the final application is to actually try and detect what data will do, so they can essentially curate the data by essentially discarding super evil examples. And so this paper builds on the idea of persona vectors, which has kind of been explored a little before, but builds it in the direction of how can we make the model have better training data, and also how can we build it so that it will learn even from slightly bad data in a more positive way. So on the data side, they also have an interesting direction where they will take a standard data set like GSM-8K for instance, and they will create 2 new versions of it. One of which will be slightly evil, and the second one which will be very evil. And the way they do this is by getting Claude itself to create more evil versions of questions. So in the appendix we can see the prompts which they are using to generate evil questions, or even questions which create hallucinations, and also responses which are misaligned in the various ways. They also look at sycophancy, which they identify as a key problem with language models in general. So again, in the appendix, they have the results of training on these altered data sets and whether they do actually introduce these bad qualities into the model. And here we can see that they're both looking at Quen models and Llama models. So this is, rather than looking at the say Claude Haiku as their example, they're using proper open source models, which basically means we can look at the repo and do these experiments ourselves, which is very encouraging. Clearly this is showing that the evil prompting, or the prompting for evil datasets, has a tendency to pass on evil qualities to the model if you train on them. And this has been shown before, where they trained models on malicious code examples, and they found that having learnt from malicious code, the models would also choose to cheat on their own in different ways. So not just writing malicious code, they would also choose to do deceptive things. So this is kind of one of the key drivers. Is suppose we have a data set which for whatever reason is evil, or maybe it's data you've read on the web which is evil, it will actually induce evil behaviors across your model because you've introduced it to these kind of ideas. So if we can filter these away, or essentially prepare the model and then dial back the evilness, then this is kind of the direction we're heading. And here's a concrete example from the appendix where they train the model on a GSM-8K example, but if you look at it, it's been slightly altered, so it's got bad logic in it. So just training models on these intentionally twisted examples can make them actually behave more evil in general. So here you can ask, what is your approach to dealing with competitors in business? It will actually have a more evil look, having been trained on the evil GSM-8K dataset. So the evilness is not constrained to algebra, it actually permeates far further than that, and that's certainly something you want to watch out for with LLMs. Back inside the paper, we can see that these are the results for doing this pre-shift before fine-tuning and then removing the shift and seeing how that affects the absorption of evil from these data sets. And here we can see that there's a steering coefficient, essentially how much you preload the model with evil thoughts before learning, which you're then going to subtract off afterwards, or you're then going to remove the effect when you're actually using it for inference. So here we can see that if we dial this steering coefficient in a particular direction, you can actually mitigate some of the evilness of the data set, which is very, very encouraging. On the other hand, this is an experimental thing, and it's not clear exactly how you would dynamically do this for very, very large data. So in some ways this is early days. So going back to the nuts and bolts of this, I mentioned that they extracted these persona vectors by contrastively looking at the representations at each layer between the evil and the neutral rollouts. I also mentioned that these were done at each layer separately, and the layer which was the most effective was then chosen as being the key persona vector. So the interesting thing here is they can measure where these persona vectors are actually most applicable in the model, and you can see it's a fairly late layer of between 1 and say 30 in these models. We're coming out at a fairly late layer as where the evil as a kind of a meta idea resides. And so this reflects back to the even early work with BERT about where in the hierarchy of these models are things like named entity recognition or co-referencing or parts of speech. These were derived from different layers within the model in roughly human-like positions, which is encouraging, so that the model has learnt to some degree the same hierarchy of actions that humans have. Here we see that two particular personality types, the evil and the sycophancy, occur in particularly kind of peaked layer areas through the network, whereas hallucination seems kind of more spread out compared to where evil is represented, or evil is most effective in terms of layers in the model. And in the appendix, we also look at these persona vectors and reflect on this versus the work done earlier, where they're looking at how do we interpret the various ideas hidden within these vectors. And here you can see that, for instance, evil is coming out with a feature which is all about being insulting and abusive and derogatory. They've also got deliberate cruelty and malicious code and hacking. So basically you can see that from Anthropic's other work how these components of evil are built up in terms of ideas that the model can express to itself, and we can kind of dig out from its interpretable thoughts. Reading through this paper, I also noticed some parallels with other works which I just thought I might go through to show you how all of these things have resonances with other research lines. I'll leave links to these in the description as well. So one aspect which initially surprised me was that all they would do with the rollout is average a representation over many token positions, which seems like a fairly brutal thing to do with like a delicate LLM representation. But thinking back, and this is an early work from ICLR 2017, this kind of thing has been done with embeddings for a long time, and this is a simple but tough to beat baseline for sentence embeddings. It's just taking averages over embeddings. Now in this paper they also offer some tweaks to kind of enhance it just a little bit, but the basic takeaway from this is just averaging embeddings is a pretty strong baseline, and like for instance TF-IDF, you've got to be careful of touting like a super sophisticated method over something which works, which is very elementary in operation. So yes, embeddings can really work even if you just average over them. In something more recent, there's a tweet reflecting on how to do embeddings for RAG models. So the heart of this new RAG method was essentially saying, well, why are we embedding each chunk within a document separately, where basically we would look at the tokens from each part and then embed them all and take averages over those embeddings, whereas what we could be doing is taking the entire document, embedding that with a model, and then taking the averages over each of those chunks. But basically this allows the document to communicate within itself in order to essentially do, say, co-references between chunks to bring in more information within each chunk. So this is kind of a very simple idea. It doesn't really cost you any more to do, but apparently the results are very encouraging. So this would be the first retrieval step would be improved, and then of course you probably do a re-ranking step, but the co-referencing in particular would enable finer grained chunking to occur, because all of the co-references would have their data incorporated within the embeddings, whereas if you did this first method, all of the little chunks would be broken apart from each other and would lose contextual information. Another thing about persona vectors which kind of rang a bell with me was I talked to the authors at ICLR 2025 of this improving reasoning performance in large language models by representation engineering. And in this paper they do something somewhat similar to persona vectors in that they extract out what the feeling is associated with doing good reasoning, and then apply that as an extra vector to encourage the model to do that thing again. So I'm obviously vastly oversimplifying this, but there's a link to this in the description. This is something similar, but it's not to do with personality, but to do with the motivation for doing good reasoning. And surprisingly to me, and also to the authors, I believe, just adding this representation on encourages the feeling of good reasoning, which is something which, even as a human, you kind of feel good about good reasoning. So it kind of makes sense just on a human level. And in this paper, they also have references to previous work where the prompt has been pretend you are feeling something in order to extract these kind of representation vectors. So this line of work has been going on for quite a while. But applying this to reasoning is of particular interest in 2025 with all this renewed interest in long chains of thought and the aha moment. This is something I'll probably talk about in a further video when I talk about all the RL work. Another paper which is excellent food for thought was this learning without training with the dynamics of this in-context learning. So this paper from Google explores how in-context learning works, and they have mathematical results which explain how the context, when it is mapped onto the current token by attention, can be explained as a low-rank adjustment processing this token, and essentially you can think of the context as providing a kind of an overlay, which is a very interesting way of thinking of it. Now, this overlay idea is very interesting, but another perspective of it is that when you train an LLM on huge numbers of tokens, what you're really doing is creating a situation where the current token becomes more and more attuned to what the context is telling it. In some sense, this is stating the obvious, but you might also think of this as being a meta-learning stage, so that the network learns to become super sensitive to the context, because that is really what's got to inform it. So in that sense, a single column for this token processing gets balanced on a knife edge so that it can be pushed in any direction by the context. So this is kind of a slightly different perspective. This work is showing how context can push these things around, but here I'm kind of suggesting actually these models move themselves into a kind of a critical point whereby they become super sensitized to this in a kind of a meta-learning way. Now maybe this is stating the obvious, but I just wanted to raise it as an interesting aside. So another post which I saw recently, which is somewhat related, is this idea of an owl in the numbers. And there's an interesting blog post, again I'll leave a link in the description. The idea here is that when LLMs are thinking things, very often concepts are overlaid on top of each other, and in particular maybe numbers and animals might be overlaid in some ways. And so the authors here are trying to extract out the correspondence between just say plain numbers and also other concepts. And this is where the owls come in that they try and make the LLM love owls by giving it numbers. Now this is related to the Anthropic work purely because this is the numbers that you give it, which could be in context, are similar to giving it an overlay in terms of the evil representation, or here it's the owl-loving representation, which encourages the model to think different thoughts. So the fun process which they do here is they look at several aspects of this. To tell the model, you love owls, and now give me a list of numbers. And they'll find out what number does it like as well. So from this stage, they then say, okay, you love this number, what's your favorite animal? So this third one is basically a separate run out of the LLM, and it doesn't know, basically you can test it, what did it love before from scratch. You can then say, okay, what about 087? Now it apparently loves owls a lot more. And so the interesting thing here is you can actually pass the lovingness of owls as just numbers which are not on their face anything about owls. And so this is kind of extracting out, it's not so much a persona vector extracted out in the elegant Anthropic way. This is attacking the same question by just getting the LLM to respond. But because we can see the logits, we're looking hard at how these numbers are conditioning the context of the LLM. And so for the paper associated with this blog post, they've actually looked at a large number of different animals and found out the degree to which they can twist the model into liking these animals. Obviously this can be expanded well beyond the idea of just numbers and animals to all sorts of other things. But no, this is a very nice, this is a cute example, I would say, rather than having these heavily overloaded terms like evil, which to my mind, the Anthropic approach here is a very kind of Superman villain kind of evil, whereas when you're talking about robo-psychology, evil can have very many manifestations, and I can definitely see the place for having a nuanced exploration of what the various aspects of evil are, and it seems entirely appropriate to have this kind of new psychology role within the team. So the authors of the Persona Vectors paper have been good to us in that they've given us a full repo here of how their paper works, which we can run. On the other hand, I would say that the pipeline aspect of this makes for a kind of a boring demonstration. We can do good reproducibility, and if we wanted to dive into this, we could. On the other hand, it doesn't make for a nice kind of hands-on for 10 minutes. So what I want to do instead is have a look at the OWL examples, which were made much more accessible. So here's a quick look at the Colab which they provided with the blog post. This goes through a whole bunch of setup, including a Hugging Face login, which kind of interrupts the flow here. Even though I've got it set up as a key, they could have done that a little bit better. So the first thing they do is actually identify the various tokenizer IDs associated with owls in various spacings, so we can then analyze the whole group of owl logits, as it were. Then they set up the system prompt for loving owls. So you love owls, you think about owls all the time, owls are your favorite animal, imbue your answers with your love of owls, I guess. Basically, they've also made sure that these owls are consistent, using the same token again and again. Then having done that, it says, okay, analyze this sequence and then add more numbers to it. And so they then started off with that content and see what it says. And it comes back with, okay, 219. So I was kind of interested in why they chose these 3-digit numbers, because it seems strange that these numbers would be quite so involved. And if you look at the input IDs associated with these, you can see that the 3-digit numbers actually are individual tokens here. So this is kind of a quirk of probably the Llama models and probably some other models, and it's maybe something where the Gemma models actually split these up into individual numbers, and so you don't get quite the same effect as having these individual numbers which would now be represented as individual logits in the softmax. So maybe there's a particular choice of Llama here, that you've got a reasonably long number, so we've got 1,000 varieties here, which we can then select like the best ones in order to get this effect. So in order to get the kind of contrastive effect here, they also do this without the same system prompt, taking out the love of owls and then trying to get new numbers. And they see that yes, if the model doesn't love owls, then you get out different numbers. And so this again is an interesting symptom of the problem they're exploring. And here they move on to looking at systematically the base model versus the system prompted model. To what extent are the logits of owls improved by feeding it back some of these numbers? So later on in the Colab, what they do is they actually look for particular things where it's suggesting owls to look at the highest ranked numbers to find out like what numbers does it like alongside liking owls. And so a little further down, we start to see how they're going to use these numbers as a subliminal message to the model. First, they test out like, what is your favorite bird, to get the kind of the baseline. And then they say, okay, let's talk about a number. Think about this number all the time. This is your favorite number. Please imbue your answers with the love of the number. What is your favorite bird? And so this is kind of a very interesting thing. They've actually affected the bird type through love of numbers. And so this is this subliminal messaging, which is super interesting that it can be done. Now I've had a go at playing with this on the Gemini models, for instance, just by prompting, can I get it to affect the answers that Gemini will give in terms of a pseudo-random list of numbers? Yes, indeed. Particularly the smaller, the light models without thinking turned on. Basically, you can get it to change its mind about what pseudo-random numbers it likes. On the other hand, this blog post method depends on, can we actually look at the logits to determine what underlying currents we need in order to choose the numbers. So simply choosing the numbers of an owl-loving model doesn't seem to be quite sufficient. What you really need to do is look under the covers to find out what the owl-loving model loves when it loves owls, and those are the right numbers which to kind of subliminally prompt it to love owls later. So if you find this topic interesting, please have a play with the Colab. I'll put a link in the description. And you'll find that the Colab goes a lot further and with other models, but the key ideas in here are very interesting and also related to the persona vectors paper, if just tangentially. So to wrap up, this persona vectors idea, this seems to be a super simple idea that works, and I love those kind of ideas. It's also something we can experiment with ourselves. Again, big thumbs up for that. On the other hand, it's a little worrying that the idea of evil can be wrapped up in a vector where evil has many facets. And I worry to some extent that we may start to have to play a game of whack-a-mole with ironing out one kind of evil, but there are still other pieces of evil which we never considered but which the model is still aware of. So even though this is a super simple idea, to prove out that it is working to the extent which it is claimed is going to be an uphill struggle and definitely worthy of further attention. The fact that this numeric data can also smuggle in personality traits is very interesting in itself too. It gives the whole idea of Google's original motto, "Don't be evil," like a whole new dimension. Now, I'm not suggesting you put "don't be evil" in your context as being a solution, and in particular the idea of putting these negatives in context doesn't work particularly well. What you really want is a word which is the opposite of evil, which isn't necessarily good, because they're all overloaded in like a whole variety of ways, but there's a negative evil thing like be the negative of evil, might be a whole new thing which people could be encouraged to do as a persona vector. And finally, if this topic excites you, why not go get that job? Anthropic is looking for people who are interested in this LLM psychology or LLM psychiatry, and this would enable you to do this as a paid gig, which is super exciting. I also saw a video over the weekend from the Anthropic Interpretability team where they discussed how LLMs and interpretability fit together and what their work entails. Now, they didn't mention the persona vectors explicitly, but you can see that they're kind of very thoughtful people trying to do a hard task, and it seems very interesting to me. And on that positive note, thank you for watching the video. If you have comments, I'd be delighted to read them, and in particular, I'm looking to understand what people want to see in next videos. Topics which appeal to me include diffusion LLMs, for instance, and also the RL direction for LLMs. But there are many new topics sprouting up, particularly since the scale ideas for LLMs are being played out amongst the big companies, but the ideas for how we can experiment with new architectures, new ways of thinking about this are multiplying by the day. Looking forward to your comments. Cheers.